on the actual screen? Nope. How do I get to the second screen? Is it above or below? There it is. Okay. So in Minnesota, we're number one in sugar beet production. We have our sugar beet growing region kind of goes into North Dakota. So between the two of us, we're the biggest sugar beet growing region in the US. And one of the things about manure application is that manure is the gift that keeps on giving. Typically with sugar beets, we're looking for a nutrient source that delivers the nitrogen early and then has kind of less nitrogen in the soil later in the season for the actual sugar production to happen. If you have a lot of excess nitrogen, that sugar production's not going to happen. Some of it's because it's going to vegetative growth, et cetera. So we're with manure, we're worried about having manure, a system that will be releasing that nitrogen late. Now, the other thing we have going on is our sugar beet production region is kind of in this northwest area of the state, down into kind of the western portion. And we have a lot of bigger dairies that are moving into this region. And we're talking on the lines of like 9,000 to 20,000 head. They are all putting in this liquid solid separation system, which potentially is changing the nutrient availability. So if we don't really know what we're working with at this point, we know the nutrients are going to be more available. So that's maybe a rather than later. So we wanted to test what does this look like in a growing season. Most of these do not have anaerobic digestion, although they're actually building them now. So might have to restart the study and see how that goes. But these are the two studies where, two sites where we did this study. Manure was applied in fall of 2020 at Nashua or fall of 2019 in Murdock, Minnesota. These are both located right near larger dairies that have this system going on. So in our case, we wanted to see where should we be putting this manure in this rotation. Typically, we're doing a corn, soybean, sugar beet, soybean, corn, sugar beet rotation. And we wanted to know, can we put manure in front of any of these and still have the same effect? Or like, should we avoid putting it in front of sugar beet, et cetera? So the first year of the 3-year rotation, we applied manure the fall before the study started. And most of these dairies are offering a high rate, which is aiming for about 195 pounds of nitrogen, plant available nitrogen per year. And the low rate for about 150 pounds of first year available nitrogen. So in this case, it's about 15,000 gallons per acre or 10,000 gallons per acre. So again, we figured let's test out what the dairies are actually offering and see how it fits into our system. Our control then was just using spring fertilizer according to the recommendations in our state. The second and third year, we did fertilizer only. We did not apply manure again, but we did take credits for manure and nitrogen as needed and tested for soil phosphorus, et cetera, and then applied fertilizers based on the recommendation. We also had all 3 crops in each year of the study. So that way we could, again, we applied them in once just for logistical reasons, but then we could see if we put it in front of corn or sugar beet or soybean, how that worked out. And then we rotated each crop each year. So it was kind of a cool study that we did. The actual dairy farm is just off of this picture, off to the east in that case. And then we had 4 replications, which you can see each crop is blocked there. So just because we have a short period of time, I'm just going to run through the results. And first, I want to talk about corn yield. So this is in bushels per acre, from 0 to 250 bushels per acre. And then we have first year, second year, third year. And the manure was applied before the first year and then repeated again after the third year. So then we kind of have that first year of repeated manure. Or each of these bars represents each of the different treatments. So fertilizer is this first bar, which is red. The manure at that low rate, which then had supplemental fertilizer if needed, is the gold bar in the middle. And then the gray bar is that manure at the high rate. So even though we had like soybeans in this rotation, which I'll show you in a minute, we did not apply further nitrogen to that, but we did apply phosphorus and potassium if the soil test needed it. But for corn, we were aiming for, this is corn following soybeans, so we're aiming for 150 pounds of nitrogen. So that means that we did potentially overapply some manure in this with the high rate. But again, we were just kind of seeing what the system shows us and what the dairies are offering. Overall, we did not see any yield differences except for that second year. This is a drought year. We did see that the manure yields were significantly higher than our spring fertilizer only plots. And then we kind of saw similar trends throughout the study, but we didn't see any statistical differences. There's enough variability in each year. But overall, it looks pretty good. Generally, manure is performing just as well as our fertilizers, maybe even slightly better in some years. Here's our soybean yield, and this is where things got a little wild. Sometimes I joke that we do dumping so my farmers don't have to, and this is a year that we found that out. In this case at Murdoch, both of these sites have, Nashua's a little closer to neutral soil, but Murdoch site has a high pH soil. It's roughly about 8. And then when you apply manure, which has organic matter and nitrate in it, or produces nitrate, you can actually drive iron deficiency chlorosis in soybean. And that's what we think happened here. We completely toasted our soybeans, like to the line where the manure was applied. So fertilizer did a lot better. We got about 35 bushels per acre. And then in Nashua, because it was the we learned our lesson and we applied a product, soy green, to kind of reduce the iron deficiency chlorosis. But also it has a closer to neutral pH at that location. But in that case, then statistically, we did not see any differences, although numerically we did see a little bit higher yields where we had applied manure actually. So that was the first year after manure application and this is what the soybeans actually look like. You can literally see to the line where we applied the manure. So again, this is pretty obviously a manure issue. It wasn't necessarily there was iron deficiency chlorosis across the entire field or anything. So again, doing dumb things so our farmers don't have to. Here's our second and third year yields for soybean, and then the first year after repeated manure. Again, we learned our lesson and applied products to make sure that we weren't seeing issues with the iron deficiency chlorosis again. And again, we saw that generally with our spring fertilizer, the yields were very similar, even where we had the manure history. But numerically, we did sometimes see maybe some increases. But again, it was only 2 sites, and a couple of these years were drought years, etc. But again, telling us a decent story. Manure is performing similarly to fertilizer. Just to show you, this is the first year, the same site. This is the first year after the manure was repeated again, and we don't see that soybean issue. So we did a better job. Here is our sugar beet yield. I'm going to go over a couple different factors. So this is the actual root yield, so the tonnage that we're pulling out of the field. And then I'll talk about sugar content and quality in a little bit here. With our first year, we did not see any statistical difference between yields. For the second year after manure, we did see that that high rate of manure had an additional benefit where we saw a little bit higher yield the second year. And then third year and the first year after repeated manure, we didn't see any statistical differences. But again, you kind of see that trend continuing where maybe there's a little bit of a bump with where we had that manure history in the fields. Here's our extractable sugar, and this is pounds of sugar extracted per acre. And we see pretty much kind of tracks with what our yield results look like, our root yield results look like. Statistically, we did not see a difference in most years, except for that second year. We actually did see more extractable sugar taken per acre, where we had that high rates of manure history. And then this is the percent sugar. And again, we did not see any differences. And this is like the big story, right? We were really concerned that applying manure to these fields, we would see a reduction in sugar quality. And we didn't see that over time. So this is actually really promising for our sugar beet growers because a lot of the crop farmers, they hadn't necessarily dealt with livestock manure in the past. So they were actually really concerned about using manure in their systems. Actually feeling a lot more confident that it can be at least the same as fertilizer, maybe in some cases. No major downside apply manure on sugar beet anywhere in the rotation that we could find. On corn, year after manure was applied. And we did have some issues with applying manure right in front of soybean on a high pH soil. Iron deficiency chlorosis seemed to be one of the bigger So we don't doing that without having any kind of product to try to reduce that if you have those conditions. So thanks to our sugar beet growers who funded this, as well as our Ag Fertilizer Research and Education Council who continued the funded portion of the experiment. And you know, follow me on LinkedIn or the platform formerly known as Twitter, which is now X. I'm on there as well. But I should have time for questions.